What would happen if after factoring your function, you end up with something like this? So have a close look here. We have minus 2x times x plus 2 and divided by x plus 3 and x plus 2. If you notice, those up here are supposed to be the x-intercepts, and those right here should be the vertical asymptotes. In reality, whenever you have a vertical asymptote, the graph should never touch that vertical asymptote. So this is kind of like a collision between a vertical asymptote and an x-intercept. So those are contradictory statements. You cannot have both at the same time, and you cannot just cancel those out and be done with it. You have to think about the effect of that cancellation. So if you just cancel those values out, it's not gonna do it for the graph. So we need to set that value apart. And we're gonna write it as x equals, sorry, I used the other tool. Give me a moment. There we go. So we're gonna use x equals minus 2, coming from x plus 2 equals 0. What is happening there? So there's gonna be an incident as Leclerc, incident as Leclerc said once. So we're gonna save this value for later, the one that caused that collision between an x-intercept and the vertical asymptote. And we're gonna cancel those out, but we're not gonna forget about those just yet. So the new function is gonna look like this. Next, you need to think about what the vertical asymptotes are. And you're gonna get the vertical asymptotes from this new version of the function. So the vertical asymptote is based on what you have in the denominator. So x plus 3 is different than 0. So you're going to get x equals minus 3. And the horizontal asymptote, since the degrees are the same, there's a tie. You have a degree 1 up there and a degree 2 down here. So if you remember, now it's about dividing the leading coefficient, minus 2 and 1. So the horizontal is at minus 2. The y-intercept, you need to evaluate the new function with 0. F of 0 is equal to minus 2 times 0 divided by 0 plus 3. So that is going to get you 0, 0. Notice how the x-intercept is based on what you have in the numerator. So in the numerator, you have minus 2x, and you said that whole thing equal to 0, you get x is equal to 0 over minus 2, or you can even forget about the minus 2, it won't make a difference. So that means that the graph is crossing both axes at 0, 0. Now, let's find some additional points like we have done in the past. We're going to evaluate the function with minus 3. The function that we're using right now is the simplified, the one after canceling those terms out. So you're doing f of minus 3 and you get minus 1. You evaluate with minus 4 and you get minus 8. This coordinate is 3, minus 1. This coordinate is minus 4, minus 8. And another coordinate would be minus 6, minus 4. Now, if you sketch the graph, it's going to look something like this. Not a perfect sketch, but you get the idea. Now, let's go back to that incident at the beginning. We cannot forget about that value. So at this point is time to evaluate the function with that value that caused that incident. You're going to evaluate the new function with the value that you had to cancel out. So you are basically evaluating f, but the new f taking a -2 as your input, and you're going to get -2 times x, which is -2, this -2, divided by -2 plus 3, this -2, replaced on every x. And you're going to get that the output is 4. The meaning of that is that collision, that incident that we had where those two values try to be appearing at the same time, both a vertical asymptote and an x-intercept, led to a cancellation, and that caused a discontinuity or a hole. So there is an open or a hollow dot on our graph. And that specific point where the graph was broken was at -2, that specific value where both collided. So x equals -2. And you have to represent that as a discontinuity or as a hole. So this is a hole, an opening on your function. And that's how you can sketch it. Now, let's get rid of everything and let me show you another example. Well, the domain, very important. The domain is still based on the original function because you are gonna jump over -3 and over -2. Notice how one represents the vertical asymptote and the other one is based on the hole or the discontinuity. Now, here, something fun is gonna happen. We're gonna cancel out x -2, but it's important that just like we have done in the past, we save that value, the value that was canceled out, x -2 equals 0. So we're going to save that value. We're going to get a new version of the function, simply being f of x equals x plus 3. And since this is a line, a linear function, is going to be represented as such. There are no vertical asymptotes, no horizontal asymptotes on a line. You can only have a y-intercept. If you evaluate the function with 0, you're going to get 0 plus 3, and the answer would be 3. And if you set the equation equal to 0, you're going to get x plus 3 equals 0, so x is equal to -3. That's your x-intercept, and the hole is going to be exactly where this function is evaluated at that value that we had to cancel out. So the coordinate is at 2, 5, and you have your other 2 points, 0, 3, -3, 0, and that would produce a line. And since there is a hole up here, that hole will be a discontinuity on your domain.